Hello, this is Mrs. Nearing, and this is a video about specific heat. And specific heat is the energy required to change the temperature of a substance. What is specific heat exactly? It's defined as the energy to change 1 gram of a substance by 1 degree Celsius. For example, the specific heat of water is 4.2 joules per gram degree Celsius. Joules is a unit of energy, Celsius is a measure of temperature, grams is a measure of mass. So that means for water, it takes 4.2 joules of energy to raise 1 gram of water by 1 degree Celsius. Substances with higher specific heats require more energy to change the temperature compared to one with a lower specific heat. So here's an example of it. Water has a specific heat of 4.2 joules per gram degree Celsius. Vegetable oil has a specific heat of 1.7. So water has a much bigger specific heat. It's about 2.5 times bigger. That means if you had 1 gram of water and 1 gram of oil, it would take a lot more energy to raise the temperature of the water. Okay, so you can think of the substance with the higher specific heat as being the one that's harder to heat. It takes more energy to get it to change its temperature. Another way of thinking about it is, well, what if I applied the same amount of energy to 2 samples of the same size? And we did this in our lab in lesson 4. We had water and vegetable oil, and we put 1 block of metal in each of those samples. They were the same size sample, and we saw the water's temperature increase by 3 degrees, whereas oil's increased by 8 degrees. So again, water has a much bigger specific heat than oil, which means if you apply the same amount of energy, water will have a smaller change in temperature. Oil will have a larger increase in temperature. That's because since oil has a lower specific heat, it's easier to heat. Or you could think of it as water has a high specific heat, so it's a lot harder to change its temperature. So to summarize the 2 things we just talked about, in order to get the same temperature change when you're comparing 2 samples, the substance with a higher specific heat will require more energy input. So it will require more energy to change the temperature. Or if you think about the scenario, if you apply the same amount of energy to your 2 samples, the one with the higher specific heat, so higher specific heat, will have a lower temperature change because the one with the higher specific heat is, you can think of it as harder to change the temperature. Harder meaning it requires more energy to take the temperature. So again, in order to get a certain temperature change, when you have a high specific heat, you need to put in a lot of energy. Other way of thinking about when you're comparing 2 samples and you apply the same amount of energy to those samples, the one with the higher specific heat will have less of a temperature change. Again, because it's harder to change the temperature of that thing with the high specific heat. So some examples from the homework. So this is from lesson 5, and we have this table of various specific heats. And 1A, explain how your calorimetry experiment would have been different if you'd used olive oil in the can instead of water. So we can see up here, if we compare the specific heats of olive oil versus water, olive oil has a lower specific heat, which means it is easier to change the temperature. So if you'd applied the same amount of heat energy to a sample of oil instead of water, you would have seen a larger temperature change with the oil. Again, because it has a lower specific heat, it takes less energy to change its temperature. So it's like easier to change the temperature. On a hot summer day, would you rather stand barefoot on a sandy beach or an asphalt driveway? So let's look over here at sand. Sand has a specific heat of 0.79. And then the asphalt driveway is 0.92. So if you put the same amount of energy in, so like if they're both, underneath that, that's going to be the sunlight. That's the amount of energy that's put in. The one with the lower specific heat will have a higher temperature change. Right, because that one's going to be easier to change its temperature. So it looks like the one with the lower specific heat is actually the sand. So the sand is going to get hotter. So which one would you rather stand on? You'd actually rather stand on the asphalt, which might be kind of surprising, because the asphalt has a higher specific heat, which I'll simplify as C. That's the abbreviation for specific heat. So if it's got a higher specific heat, it will have a lower temperature change, because this substance is going to be harder to change its temperature. Okay. Looking ahead here, here's one from lesson 4. You have a sample of oil and sample of water, both the same mass, same initial temperature. You place sample of oil on one plate and the water on the other plate. You heat both until they reach a temperature of 40 degrees. So you have oil and you have water. They're the same mass, same everything else. They're both going to increase in temperature from 20 degrees to 40 degrees. And we know from earlier that water has a specific heat of 4.2 joules per gram degree Celsius, and oil was about, I think it was about 1.8 roughly. So this one water has a higher specific heat, right? Which again means it takes more energy to change the temperature. So if you're changing the temperature of both samples by the same amount, so notice they both have the same temperature change, your water sample is harder to heat because it has a higher specific heat, so that must have taken more energy to heat your water than it did to heat the oil. Again, lower specific heat over here, low specific heat value means it is easier to heat. Water has the higher specific heat, so the water gained more energy than the oil because it's harder to change the temperature of the water than the oil. Here's some more examples from lesson 4 homework. Specific heat of aluminum is double that of copper. If you replace both of them in boiling water bath, which would increase in temperature faster? So this is an example where we're thinking about applying the same amount of energy to both samples. So when you have the same energy input, the substance with the lower specific heat will have a larger temperature change. So the metal that would increase in temperature faster would be the one with the lower specific heat, which it looks like here we're saying copper. So copper will increase in temperature faster. It has a lower specific heat. Again, the way I think of this is it's the one that is like easier to heat, meaning it's going to take less energy to change the temperature of your copper sample. Think about number 3. If you're thinking about a real life example, if you have some metal keys sitting out in the sun versus a plastic pair of sunglasses, metal tends to have a low specific heat. So it is very easy to change the temperature, meaning not much energy required to change the temperature. So if you put a piece of metal and a piece of plastic, which has a higher specific heat, out in the sunlight and apply the same amount of same amount of energy to those two objects, the metal is going to have a higher change in temperature. So those are the ones that it's going to be more painful to pick up the metal keys that's been sitting out in the sun versus your plastic pair of sunglasses because they're going to have changed temperature more. So again, to summarize, when you're comparing substances, which is what we'll most often have you do when we're thinking about the concept of specific heat, when you say, what does it mean to have a high specific heat? So like water has a higher specific heat than oil. What does that mean? That means that if you compare a sample of water and oil that are the same size, the same mass, it requires more energy to change the temperature of the water sample. Another way of thinking about it is if you apply the same amount of energy to both samples, the water will have a lower temperature change. And that's because water requires more energy to change its temperature. So that's a little bit about specific heat. I hope that this helps. You can always email me if you have any questions.